Everybody. So the recording started a few minutes after today. There was a presentation from the career coaching and employer connection department. So definitely some people worth reaching out to, because the reason we're here at school is to get those good jobs afterwards. And now I guess it's time to jump back into our content, the fun and exciting video game development. I have tons of fun with this class, preparing for it and then talking about this stuff. I really enjoy it. I hope y'all are enjoying it as well, not getting completely overwhelmed. It was an hour or two ago. I glanced at what was on the discussion board at this point, and when I set that discussion board up, y'all may have noticed the one for the I guess last module now, because it's after 1 o'clock on a Wednesday, so we're moving on to the next module. But on the previous module, the assignment was talking about graphics, or the topic was about graphics. And I kind of wondered if I was going to get a one-word discussion board posting from anybody along those lines. Something like somebody just posted the word Zork or something, because that was a very fun game. Probably a little bit before any of you all's time, but I remember playing it when I was a kid. If you're not familiar with that, you can just Google it. Z-O-R-K. It's a mid-70s command prompt, win in the terminal sort of game. But it definitely related to graphics because it was way before the days of graphics. I was wondering if anybody was going to post that. One thing I did notice is there was some mention of the different quality in devices. I think some people might still have an old screen that or monitor they picked up at Goodwill for a couple bucks because they were short on cash. Or some people might have the newest, fanciest 4K monitor, and technology improves. That is another advantage. That is one of the biggest advantages of vector graphics, like we were looking at last module, and a little bit today, because there's still a little bit more, one more thing on the minimum amount to cover on that. But the vector graphics, it's not a graphical thing, it's an equation. So we stored an equation, and then whenever it's time to show those graphics, the machine that is displaying them just runs through that equation. So then the output is relative to the display for the machine. So that's one of the biggest advantages of vector graphics. That's why they're most commonly used, because then we don't have to adjust for the different screens and make different versions for low quality screens or different versions for high quality screens. We just save our graphics in the form of an equation, and then the computer figures out, the computer just runs through that equation when it's time to display those graphics. So we kind of looked at some 2D graphics, and then instead of drawing every frame of the animation, kind of like Walt Disney had to do way back in the day, or the early Bugs Bunny style cartoons where every frame had to be drawn by hand, and then all those images put together, that's very time consuming. If you have time, it's a good thing to practice. It gives you a very nice perspective on what all these automated features are doing. Just doing a couple small ones there, but it is very time consuming. It's a lot easier if we just draw the image and have the computer tell the computer we want this animated in both 2D and 3D. So we saw the 2D one quickly. There's another alternative we're going to look at today after we finish going over the 3D animation thing. And I think I'm going to do the graphics on my Mac today, because earlier this morning I was doing some stuff and my Windows machine seems determined to update. And apparently it's a big update. It filled up my hard drive, ran out of space, and then I have the my Google Drive is synced to all my machines. So then it went and tried to fill up my Google Drive and ran out of space, and then kind of kicked me out of what I was trying to do because it wanted to update. Usually only tries to do that once a day, but I'm still going to do the graphics on my MacBook, which the pieces of software we will be looking at are the ones that are essentially the same. The only differences are the obvious exceptions that would always apply between a Windows and Mac machine. Like to select all, instead of pushing Control A on the Windows machine, we push Command A on the Mac. But all the buttons on the interface and things are still in the same spot and all of that. So the stuff should be very interchangeable. It should be. I haven't used GameMaker on a Mac yet. I did have to install that. So if the buttons aren't there, it might be good for the class example of just the process of looking for buttons. Let's see, before we get started, any other notes? Oh, yes, and obviously we spent an entire module talking about graphics, and it's drifting over, and I'm quite willing to push back the other one for graphics. It's kind of an important thing. This isn't an art class. This is a programming class, but we still want to know about it. For example, the people studying this in terms of an art class or the engineering style design classes, they never look at how the data is stored. And that was kind of the priority for us in here, because that this is more of a programming course, but we definitely need to be aware of it. So wanted to include it as an assignment, but I just made it an extra credit assignment. So for your final project, I do want to see original artwork, but it's not an art class. It doesn't have to be good artwork. It doesn't have to be great artwork. I just want to see your artwork, basically. And now to show familiarity with the tools and basic understanding of it. As we're more worried about programming in here. So I sent out some files. Yesterday in my office hours, I took about 45 minutes preparing for today, and I went ahead and did some animations for a game. We'll talk about that in a moment. One of those being that, I'll put quote marks, that dragon shape we started from our class example the other day. It looked, had legs and wings and a tail and a head, the basic idea of a dragon. Still a long way from a final draft, but thought I'd go ahead and animate that and then use that in a game to show another alternative to get 2D animations. It's one that's actually a little bit more commonly used. And a lot of people think it's easier to work with, because with the 3D models, we have the advantage, we can visualize it a little bit better. It's not a flat surface where we have to think about our perspective and all that stuff we studied in like middle school art classes. I think everybody in America does that lesson in middle school art class of painting train tracks and learning about perspective, going off to a point in the distance. We have to think about all that with 2D stuff. With 3D, we can actually think about a model, sculpt it. We saw the other day in Blender, there's even some sculpting tools, and we can treat it just like a wad of clay and sculpt it into the shape we want. So those can be a little bit easier, and then we just do a 2-dimensional export from that. But I still wanted to cover this process of animation, so we're going to go over the steps for animating that shape we did. Though I did go ahead and make an animated one, which is in those files I sent out today. And then the other two, we're just going to talk about the animations for them, because just to kind of get an introduction. But all the steps for it will have been covered in what we see here in just a moment, and some brief talking afterwards. Does anybody have any questions before we get started? Okay, I assume that means no questions. So I'll go ahead and share screen here. And yeah, my Windows machine was determined to update and completely ran me out of storage space and shut down the program I was working on in the middle of something. It's like, that's really annoying. Usually only does that once a day, but I'll plug up a terabyte hard drive or something after this evening when I go to bed and let it happen overnight. That way I won't try to stop what I'm doing or anything. I had that button. Okay. Sorry. The Mac had a button I hadn't seen before. I didn't realize I could hide that. There we go. And that way those buttons aren't in the way. So let's open up that image we were looking at the other day and get started with that. I went ahead and downloaded the files. So here's the one we were on the other day, the dragon shape roughly. And then over here are some files for our example of using GameMaker. the quick pass on the basics of moving things and creating and destroying objects and collisions and just some basic stuff. And you can probably figure out the game I had in mind. We'll talk about that afterwards. But there's a dragon image, a fireball image, and a castle image. So kind of like a shooting gallery thing. We'll see that here in a few moments. That would make it a good starting example to show most of the buttons. But GameMaker, a lot of people find it very intuitive. It's kind of a nice one to work with. So, all right, so here's that shape we started with the other day. Kind of the rough idea of a dragon. Got some wings, legs, head. A lot of details to work in, right? This chest here probably shouldn't be sharp edges. Same thing with the ankles and a lot of details we could work in still, but that gets us a good starting point to cover the steps. And that file will make a good starting point if you're new to the 3D modeling stuff, is just to start playing around with stuff. And we also, if I switch over to edit mode, we can see it. We only did half the dragon. Symmetry is your friend, very much so for doing this stuff, because if you're doing something symmetric, and that means you only actually have to do half the work and the computer can just fill in the rest by duplicating what you did, like a mirror image of it. And the same thing can apply for with our armatures or skeletons to make it move. So I'm going to jump ahead and assume this is a finished, the finished model. We got our skin looking the way we want it to, and we'll go in here and start putting in a skeleton so we can animate this. So again, we'll come up to the add menu here in the layout, and under armature, we want to add a single bone to start with. And then everything else, we use the extrusion. So the E key on the keyboard to extrude another bone out of that. And then we'll build all the bones up as extrusions from a single one. It does have to be built from a single bone in that manner in order to animate things. So first thing we want to do is get it into place. So you can see here, it's kind of hidden, but turn the little movement things off, we can't see it unless we're looking directly at it. So one thing that can be useful, you might notice over here on the right hand side, some more menus showed up, including these two down here that look like bones. One looks like a single bone and the other one looks like a stick man. That's our options for the armature. So we can give it a name and keep track of things. That's often a good idea. Then way down here, there's an option for Viewport Display. Oh, I'm on the Mac. The scroll wheel's backwards on it. I was like, why isn't that scrolling? I forgot that it goes backwards. But if we click on the stickman looking button, then under Viewport Display is this button for in front. And that makes it so that our armature shows through any skins. That way we can see it the whole time. We don't have to try to work with it by estimating. And the first thing is we'll move this into place. And then there's a lot of things that would come down just kind of personal style. What I like to do is start with a backbone and then build it off the backbone. That's for living things. We'll see some other stuff here in a few minutes. So it looks like it's pointing the wrong way. So remember from the day, the R will rotate it, and then we can hit X, Y, or Z to restrict what axis we're on. So it looks like if we rotate it around the X-axis, it would point the proper way for a backbone on this dragon object. And with rotating, I like to have the move tool there, just from experimenting with different things. That's what you're going to want to do with practice. But what I found makes things easy to work with. Well, I'll show it. If my mouse is way out here and I push R, I got a lot of control. And escape will just cancel out of that. But if my mouse is down here close to the center and I push R, just a little bitty movement on the mouse moves that thing a long ways. And it should make sense that as we go further out an angle, there's a wider range. So it can be good to move out a little ways. So I like to use something like turn on the scale, the move tool or the scale tool. And that way there's some little grabbing points near the thing. So I put my mouse about where that arrow is, then hit R and then X to restrict the rotation to the X axis and just bend that down until it's in about the right position. And again, one of the most important buttons is the transforms, the little orange square. So we could also just type that rotation in, something close to a 90-degree rotation in this case. Once we're there, we can just kind of move it about where it needs to be. And I think it needs to be a little bit bigger, right? That's not much of a backbone. So I'm going to hit scale, S to scale, and then Y to scale on the Y direction. And then kind of move that into place. Oh, that's too much. I'm going to hit undo, and scale Y. And I was looking for a length that puts those little nubs right about where the shoulders would be, the shoulders and hips, I guess. Now we can come straight out from there into this leg, or straight out from back here into this other leg. And it does, you do want to keep forethought in mind. Think about what the next couple steps are going to be so that you can kind of get ready for those. And then holding down the scroll wheel allows us to turn so we can check from different angles and make sure it seems like about the right spot. Because you don't want to do it over and over again. Right? You want to do things once. So a little bit of forethought goes a long way with these. That looks like it'll line up on the legs. So then we can go in edit mode and build the rest of the skeleton from this first bone. So I'll click on the little knob here at the front. I'll switch to the selection tool I like. And here we can select different ways. We can select the whole bone, the knob at the front, back, the knob at the front. So I've also found it's very useful to have those arrows on, like the move tool or the scale tool, something to help reference what is currently selected. Then we can just push E to extrude, E, and extrude that out to about where the base of the neck is. E, extrude another one for the neck, then E, extrude one for all the head stuff there. And then maybe zoom in and do little adjustments to make sure everything's in the right spot. So move that up a little, forward a little, grab the front end of it, move it forward just a little bit, where it looks like that bone is going to in a good spot to control all the skin from the head wrapped around it. And once that looks good, we can come back and get the tail the same way. I'll extrude back to the base of the tail. E to extrude, E to extrude, E to extrude. And probably not going to do it in our animations, but something like a tail has lots of movement. So we'll probably want lots of bones to be able to control that movement. And when I extruded that tail, you might remember from the other day, it wasn't just one long extrusion. I made several segments along the way, and that way the faces and the edges and vertices, they form some creases where the computer's going to try to bend at creases first if it can. So that we also have control over how the skin's going to flex that way as well. I just add in a few more polygons. And once again, kind of use the mouse wheel, click and drag around to rotate in space, or view in space, and hold shift and drag to pan. It looks like that got a little off straight. So I'm going to try to move and grab those ends one at a time and move them back to about the center of the tail. That'll probably work. So we have the backbone and the tail. Now we need to do the legs and the wings. And this is another one with that point that I was trying to make just a moment ago, that it's symmetric. So our right legs should match our left legs. Same thing with the wings, not wheels. Our right wing should line up and match our left wing. So we're going to make we can use that symmetry to our advantage by a copy and flip, or duplicate is the command we'll want. So I'm going to come up here to this little knob where the shoulder would be, and I'll do several extrusions, which what I like to do is do enough extrusions, make the number of bones I want, and then I'll put them all in place afterwards. So E to extrude and come down to about where that leg starts. E, come over, there's one going down, another one, E, and then come out for the foot. That's the bone, that's the right number of bones, but as I spin around, we can see that's definitely not in the right spot. So I'm gonna come back here and just kind of move those into the right spot. So there's, I can go there, somewhere around there. Maybe move this one up just a little. And it can be a little time consuming, as you can see here. You want to carefully move things around, make sure everything is in what you feel is the right spot to control that animation. And once again, it is something that takes quite a bit of practice. So we'll look at it from that angle. And remember, we can click on the little dots to look straight on. So looking straight on, looks like that one might be a little low. And well, I think they're back too far. So move that up right where the front of it needs to be. And kind of get that in about the right spot, and just we can move it in 3 dimensions, but we have a whole lot more control if we move it in just 1 dimension at a time, which should seem a fairly obvious point, right? And it fits with a general concept I often express with programming of lots of small steps are better for a computer than a few big steps. Like when we're writing code, which we're past the point of typing, we still have some C# stuff to type later in the semester. But when we're writing code, lots of short lines can be better than a few complicated lines. And the only difference is it might make the complicated lines might make your text file look shorter and better, but that doesn't mean it's better for the computer. And in some cases, it is actually worse for the computer. But that's beyond the scope of this class. We're talking about the graphics. So just slowly move it around, look at different angles until it seems like it's in the right spot for the bones for that leg. So we're good. And with a little bit of forethought, what I was kind of looking for here, you see this bone here that's almost horizontal? I'm thinking an easy way to make that leg move forward and back like it's walking would be just to rotate that. Obviously not a final draft animation, but that'll give us something quick to work with today. Or just rotating that vertical one, the rest of those bones are going to rotate with it and kind of give the illusion of walking. So that'll work. So now, well, maybe I could bring that one down just a little. That one down just a little. think everything's kind of inside there. We'll see what it looks like. The ones in that file I sent out, it does work. So this is the steps for that. Just kind of adjust it, some undo and redo and things like that. So now we can do the other front leg, and this is one of the places we can just use symmetry because the other front leg is exactly the same. It's just mirrored across there. So I'm going to select all of these. So make the first selection and then hold Shift. And if you click in the middle of the bone, it'll select the whole bone. So I'm going to select that whole leg. And then to duplicate something, just push the D key. Or sorry, Control D. It's like Command D on a Mac. Control D. Oh, Alt D. Oh, Shift D. It might be that on the Windows too. I forgot the thing. So Shift D gives us a duplicate of that leg. I'm going to undo that since I forgot the keyboard shortcut. Shift D will make a duplicate of it, and we can drag that around, put it in different spots. But we can work with the symmetry. So I'm going to start with it in the same spot. So I'm going to right click so that it doesn't move it. So that dragging right click didn't accept that, but we still have the duplicate there. And now we can flip that by scaling it. So if we push scale, and I'll just move in some direction. So now I'm going to use the little window here, the resize window, which is our scale. So we talked about this before, very briefly. Talked about how it was easy, so it's built into most of our engines. But when we scale things, numbers bigger than 1, stretch them out, make them bigger. Numbers between 0 and 1, bring them down, make them smaller. And negative numbers will kind of continue that small thing and then go out the other side. So by a negative scale value, we flip it. So I'm going to actually use the exact values and keep the X and Y exactly the same scale. So that's ×1 for both of those, it doesn't change. But then the X scale, because I want to flip it across the Y axis, so I want to change the X size to -1. And then that gives an exact duplicate that's a mirror image. And then we can just move that into place where it needs to be. Which is basically just that front little knob lining up. I might have been looking at a strange angle there. We can see just duplicate it, Shift D to duplicate, then S to scale, and just make some movement so you get the little menu over here, which might be collapsed, but you can expand it, and then type in the numbers that you want to scale, which is a -1 on one of the axes and just 1 on the other axis, because when we multiply by -1, that flips us across our axis. And when we multiply by 1, it stays the same for the other two. So we can do the same thing for our other leg. Let's see, I'll extrude something to come over to what's really the start of the leg. Then this top part of the leg, the bone that's going to spin in order to make it move. Sort of an upper leg, a lower leg, then a foot. And now I'll just move each one into position. Let's see if I look at the top. Maybe if I look at the bottom. Okay, yeah. You kind of see where the front of that foot is. So I'll get the foot close to there. The ankle somewhere near the ankle area. And lots of adjustments, holding on the scroll wheel to move where it needs to be. Let's see that. Probably go up there. This one up here. And we have to constantly come back and look at different angles until we find just the right one. Well, that looks like it's way off there. In this angle, it looks like I should be way over here somewhere. And just, yeah, tedious movements until we get it in the position we want. That looks fairly well centered in that leg from quite a few angles. So hopefully that'll work. So now I'll select all of those bones that relate to the leg. Select the first one, then hold Shift for multiple selections. Click all of those, then Shift D to duplicate. And then I'm going to right click so that it doesn't do any movement. And scale, which we just start scaling to get our menu. And the scale we actually want is exactly -1, 1, 1. Whoops. 1. Which turns it around. Then we should be able to just slide it down the x-axis to the right position. You see how symmetry made that work a whole lot easier? Only had to do one side instead of both of them. So keep, obviously you'll focus on the step you're working on, but keep the coming steps in mind and look for things like symmetry that'll cut out some of your work. I guess the wings are the next one, which is a similar thing. So I'll just come over here, do like the shoulder spot. Here, that central connection. I can't quite tell which one I'm connecting to there. I think that was the original middle. So then from there, I'll just extrude and get up to kind of the start of the wings. Then E to extrude to the first section, second section, third section. That'll work. And now once again, just kind of move those into place. Sort of centered around that skin. That'll probably work. That's the steps. And I have one, I already sent one that's finally animated. So really we're just worried about the steps here. Don't need to spend a whole lot of our class time going over this. And it does take a little bit of time. So for class here, it's pretty much the steps and then lab time to practice those steps later. So again, Shift D to duplicate, and then I'm going to right click to avoid accepting any changes, or clicking in a different spot to make sure you got a duplicate, and then just set the move on the duplicate to 0. Then we can hit S to scale. And once the scale menu's here, we want to scale it by -1, 1, 1. And that gives us a mirror image. So we can just grab the little X arrow handle and slide that over here for the other side. Might be a little off, but then we can make fine adjustments afterwards. I think it'll probably be okay here. And that gives us a skeleton for this so we can move around. So we'll always have to do at least that much. There's another thing we can do. I'm going to go ahead and save this. There's another thing we can do called inverse kinematics, big fancy name. That's all the technical physics terms for it. And getting into physics equations, it gets really complicated, and there's a lot more technical terms. The calculations are from analytical mechanics and dynamics, so it involves tensor mathematics, which most people which don't show up till like 500 level math classes. Some people might see tensors in 400 level math classes. So a bunch of big fancy words. So as you look around and, after you practice and go to expand your things, you're probably going to come across those words: inverse kinematics, all kinds of big words, makes the documentation and tutorials on it sound super complicated. What it is the old marionette puppets. Has everybody seen Marionette? Know what I'm talking about? The puppets where there's a bunch of joints and stuff. A whole lot like that skeleton we just put together here. And then instead of like Jim Henson puppets where we stick our hand inside the puppet, there's strings going up and somebody would be above the stage controlling each of the strings. That's what inverse kinematics is. So maybe some intuition will help you get that straight. And it can be a little complicated, just like moving those puppets, right? Just because we pull up on the right string doesn't mean the puppet's going to do what we want it to do. It takes a lot of practice. So a similar thing there. It's available. There's going to be lots and lots of big words when you see it. So keep in mind that it's the marionette puppets. So really, just like the puppets, our options on what we can do is pull the string or release the string. Right? We might be able to move it back and forth a little while we're doing it, but really our options for controlling inverse kinematics are to pull the string or release the string. So maybe that'll, when you take, after you've had some practice and expand to that step, maybe knowing that thinking about it like a puppet will help you make more sense of it. That's what helps me make more sense of it, because the big words get really complicated really quick. And I know what all the big words mean from math and physics classes, and it still confuses me quite a bit. So if you just stumble across that terminology, it's probably quite overwhelming. It has things like in a human shape, if you stop and think about it, when we walk, all we really think about is our ankle. Like, pay very close attention without trying to add extra thoughts into your process of walking. And you'll notice that the only thing you're thinking about is where does the ankle go? And everything else just comes along with your ankle. So in order to control the entire leg, all we need is the ankle. Same thing with the arm. All we really need is our wrist. Our fingers are separate, but if we just control where the wrist goes, the rest of the arm comes along with it. So we can do more movements in fewer actions, but it definitely takes a lot of practice, because just like the old style marionette puppets, which is the virtual version of, it takes a long time to get to learn to move those puppets correctly. Same thing with the virtual models. So I'm just going to stop with the regular one, but it would have like an extra bone sticking out behind the ankles that has all of our control features, functions to it. And then everything else just comes along with the ankle. That gives us some bones to work with. Hopefully they'll be in the right spot. A slow, tedious process. Take your time. Focus on the step at hand, but remember the coming step. So it's one that you want to approach with a plan, and that way you can use things like symmetry to your advantage. So that's our skeleton and our skin. And our skin, we only drew half of it by applying that mirror modifier. So I go back to selecting that. And under modifiers, once we're ready, there's a button to apply the modifiers. Don't I have an apply button? It's in a different spot on the MacBook, apparently. Oh, there it is. And once we're ready, that is in a different spot. There, on the Windows machine, there is just a regular looking button that says apply. We hit apply, and now if we glance back at edit mode, we can see the whole thing is one mesh now. It's not just a preview of what it's going to look like. And the final step, just like we saw in 2D graphics, is to assign that skeleton as the parent of the skin. Right? Because just like us, sometimes our first intuition might get that backwards. Right? We might want to think we want to make the skin the parent of the skeleton, But remember, the skeleton is the more important part. You are a skeleton wrapped in skin. For example, victims of house fires, sometimes they might have severe third-degree burns or something. We can live without our skin. We cannot live without our skeleton. One of them is much more important, even though it's internal and not the one we immediately think about. Same thing with our models. The skeleton is the more important one. We could put a different skin on here, right? We did the scratch image here. We'll set up all the motions in the scratch image. Then later, once time is allowed, have a bunch of fine details worked into that starting mesh we had. Then we can copy the skeleton that already knows all those movements over to the new skin, and it all work the same. So the skeleton is kind of the priority. We want the skeleton to be the parent. So the order of selection matters. So select the skin either from here, or if you can't get a good selection, the list over at the right makes it much more obvious what we're selecting. Select our skin first. Oh, and double click on this list to rename things. Just keep it straight. It's a good idea. So I'll call this dragon skeleton. So we want to select the skin first, and then hold, if you're on the list, it's Control, and if select the other one, and if you're over here, it's Shift and select the second one. And then select the second one, skin first, then skeleton, and then Control P, which is definitely going to be different on the Mac. I'll try Control P first. Oh, that kind of worked. Did I do that backwards? Skeleton, then skin, Control P. Oh, this isn't showing the option I was expecting. Skin, skeleton, then skeleton. And hit Control P. Oh, there it is. And it's best to try automatic weights. So that way we don't have to go in and do all that weight painting and say which section of skin applies to which bones. This is open source software. And one thing that often happens in open source software is the people that need a big project will practice or do several versions. And the versions that they don't use, they don't want to be wasted. So they'll put it in open source software. And the automatic weights are very good here. Like, it's one that probably started from some big name Hollywood custom software, and it was just the version they didn't use. So like the programmer's like, well, we don't want to waste this. Let's throw it into the open source software. And now you'll see it collapsed, and we have to expand that skeleton object in order to see the skin for it. So they're linked together. So now when we move our skeleton, the skin should follow. And if we select the skin, we have the weight painting option, so we can assign which section of the mesh is moves with which particular bone. But with the automatic weight painting, hopefully we can just select our skeleton and then switch to pose mode and do some checks on the ones we want. So we want to flap our wings for a dragon. So I'm going to select this first bone and hit R to rotate. And well, to flap the wings here, we can see it just needs to go around the Y axis, the green one. So I'll hit Y to restrict it there. And as I move up and down, looks like it's just that wing moving. Then escape to not do any of those. But if we do move it, rotate, then Alt R. The Alt R on both machines. So I guess on the Mac, it's technically going to be your Option R. That returns to the original position. But escape works too, just checking the movements. So check the other wing, but they're symmetric, so that should be kind of the same thing, yeah. So it looks like those two bones can control our wings. The head here, probably just move back and forth for the head. So I'll try R, and restrict it to the Z axis. That way it's only going around the one axis. That's not a good angle to look at it. So RZ, looks like the head can look back and forth. The legs, what I was hoping for is that this bone will be able to rotate, and then the rest of it will come along with it. So we first rotate, restrict it to the x-axis. Looks like the right thing's coming along. And we just want to check all of our stuff that way. And I already did a finished version, so we have a finished version to use for the game here. I'll open that up here in just a second. Actually, I'll go ahead and open that up. Do those steps make sense? Because that's the steps that are, it's kind of a homework assignment. I really, really want you all to give that a try. But it's listed as extra credit to help imply that there is no due date on that. Just take your time, practice around with it. And I want to see original artwork. It's not an art class, so it doesn't have to be good artwork. I just want it to be original artwork for our final project. So yeah, there's that assignment there, assignment / extra credit thing. But this stuff can be really fun. And there's also that discussion board is still open, so that if in random practice at these skills, if you do something that you're really proud of, share it with your classmates. Especially with graphics though, if you had some experience with graphics before, make sure you note that when you share it with your classmates. Right? If you're going to go in and add textures and make, be very cautious about like where a metal axe would have rusty parts versus shiny reflective parts and things like that. Make sure you let your classmates know that you already have a lot of experience with this software. But yeah, if you do something you really like, there's a spot to share it with your classmates. And it does take random. It does take a lot of practice. So sometimes just random practice is a great way to start. And if you make something you really like, you can go on that discussion board and tell your classmates, and I'll look at it as well. I will interact on that discussion board, send replies and stuff. Be like, yeah, I'm brand new to Blender, and I was really happy with this this rowboat I just made or something for a prop in a game. Or I guess a boat's kind of an important aspect, an important tool in a lot of games. So now we can go move these things. I'll go ahead and jump over to the animation. So we have these different tabs. We have the animation controls down here at the bottom in our regular layout view. But when they put the user interface together, they already set up what's probably the most popular controls for working with this. We have our dope sheet down at the bottom. That's the step-by-step looking at each frame one at a time. The traditional term for that's dope sheet, going all the way back to like the 1920s or before movies, where we have to, the director might need to focus on each single frame of the movie. So the terminology for it just passed on through to this. So we have our dope sheet where we set up our keyframes, the important ones, and the computer will fill in the gaps between the keyframes. It turned off the green view. I'm just going to leave it on gray here. Remember, we have different views that we can look at it in. But really what we need to worry about here is the skeleton, and then we get a preview mode to see what's happening. So what I always like to do is set the starting point. So with the layout section here in pose mode, you'll push A to select all the bones, and then I as an insert, or I to bring in the set a keyframe for location, rotation, scale, or location and rotation, or all three of them. And I'm just going to do all three of them. And that's an important thing that we're going to look at here in a few minutes. That we'll do this animation here. I'm expecting about 7 minutes on it. and like 7 minutes or so to do the 2 animations, and then we'll take a break, and then we'll look at the other ones quickly before we jump into GameMaker. So I like to do the first frame, and I think I'll do maybe 20 frames of walking, 20 frame walk. So then I'll go to frame 21. You can click here and get to it, and that drags around. Or down here at the bottom, there's a spot to just type in the frame we want. Let's go to frame 21 and insert the same keyframe. So again, everything selected, hit I, and lock the location, rotation, and scale in place here. So that way, if it's 20 frames, that last frame is going to be one before the starting point. So when it loops back around, it'll be nice and smooth. So that'll get the walking animation, which then puts our starting point. Then we can treat frame 21 as a second starting point, and let's do 20 frames of flying and kind of repeat that. So we'll come over to frame 41. You can click on it here, or just come down here and manually type in a 41 and insert those things again. So then frames 1 through 20 are going to be a walking animation, and frames 21 through 40 are going to be a flying animation, is my plan here. Does that make sense? And y'all see why I went 1 frame past it to, that way there's not a duplicate frame at the beginning, at the last frame and first frame, whenever it loops, isn't duplicated. The last frame is 1 frame before the next start, 1 frame before the starting point. So now I guess we can do the walking first. So we have these controls down here of where we're going to start, where we're going to end. So I'll do a 20 frame walking animation. Goes from 1 to 20. And I guess somewhere about a third in, I'm going to grab this front leg. And quadrupeds walk differently. So some of them walk, the same side goes outward or inward at the same time. And other ones, so some walk diagonal and some walk on the same side. So that's different animal to animal, takes a little adjustments. For a quick version, I'm just going to rotate, I'm going to do side to side so that the front leg goes forward and the back leg goes back, and the other side goes inward, which is how, actually most of them do both. That would be how canines and horses run, but the opposite of how a cat runs. I think that's the order. Yeah, it's not even consistent between which ones are walks and which ones are runs for different animals. So it does take some time and adjustments to make sure it looks right for your animal. I'm just going to do an outline. So I'm going to rotate that 1 bone up near the hip around the x-axis forward just a little. And I'll do the same thing on the back leg. Grab that bone, rotate that around the x-axis backward a little. And on the other side, I'll take the front leg, R to rotate, X, so it's the x-axis, and get that backwards. And then the back leg, same thing. That top bone, rotate around the x-axis, forward just a little. And it looks like it blended together. That'll be fine. The steps are the important one here. We are restricted on time. Maybe while we're doing that, I'll have the dragon look back and forth. So I'll grab the head bone, rotate, restrict it to the z-axis, and look a little bit to his right. And if his head's going right, might be good for his tail to go left. So and this is something I usually do in 2 steps. So I'll bring it left and up, and then on the next one, I'll bring it right and down. So instead of doing that all at once, I like to do it in 2 steps. So like rotate Z to bring it a little bit to the left, and then rotate X to bring it a little bit up. That's our next position in the walking frame. So then hit A to select all of them. Then I can insert a keyframe for the transform data, the location, rotation, and scale on all of them. And then we can go repeat it on the other side. So somewhere over here on, oh, not that far up. Somewhere over here near the, about 2/3 of the way through the walking animation, I'll repeat that. And I'm going to start by going back to the original position and just do the opposite of what I did that time. So push Alt R or Option R if you're on a Mac, but if you're on a Mac, you're probably quite used to people saying Alt R and knowing exactly what button they're talking about. And I'll do the opposite. So this time, here on the dragon's left side, the front leg, I'll hit RX. Oh, that one went forward last time. Undo that. Control Z or Command Z to undo. Okay. RX and bring it inward a little. Same thing on the back leg. RX and bring it inward a little. Which they're overlapping, but I'm going to ignore that. Try to ignore that some here. It's the steps. Hopefully those steps are making sense. Just grab the most important bone in that movement, and the rest of them are going to come along with it. Which again is a time-consuming thing, because really for a walk, we should rotate a little and bend the knee, bend the ankle, and have several movements in there. But for the steps, I'm just going to do the one. It's just more of the same thing. Grab the appropriate bone and move it. So R, X, and then bring this one forward. And on the back leg, R to rotate, X for the axis we want. And again, the opposite movements. So the head, I'll do R, Z, and move it a little bit to the left this time. And the tail, last time went left and up. This time I'll grab that first bone of the tail and rotate Z to go to the dragon's right, stage right, I guess. That's what keeps confusing me when I'm trying to say these things. And then RX to bring it down just a little. And that's the steps. I was talking the whole time I made them. And then once again, A to select everything, I to insert a keyframe, and lock all three of our transform things into place. Now we're set to go from 1 to 20. So if we run that, maybe not the best walk, but the general idea is there, right? That dragon would definitely be tripping and falling. If that was the animation, there'd be a trip and fall thing where those feet are intersecting with each other. So that really the body should probably be scaled out longer for that. But that's the fine details afterwards. We can see it. It's the rough idea of a walk when things are in place. And now we can go ahead and do a quick flying animation along the same way. So our flying animation was going to go from frame 21 to frame 40. That's those next 20 steps. We had got our first and last one. And I'm going to go not quite in half. And I'm thinking I don't have wings, so I can't rely on my own tuition. But it seems like it takes things like wings raised slowly, but then flat quickly, right? I'm going to go slow and then fast on the downward. So I'm going to take half of the time to raise upward, maybe a little less than half. The first 9 frames to go upward. I'll just leave the head and everything and just grab this first wing. Hopefully this will work. R to rotate, Y to bring us up around the Y axis. And then I'll R, Y, Got all of them, RY, RY, to curl the wing up. And then when we flap it down, it'll wrap around again to get like extra force in there. Which is based roughly off of watching birds and insects fly. Seems like up takes longer than down, and then there's some curvature involved to help catch air. Same thing over here, RY, RY. And just want to be slow, careful, thoughtful about what you're doing, and keep in mind how living things move when you're doing live creatures, animating creatures like this. Is if you think about yourself, you'll get some intuition on it, right? We have lots of joints in our arm, so no single joint is moving very much. Each joint makes a small change, and then by the end, all those small changes have added up to something big. So you want to be careful making really big changes on one joint. That starts looking natural. There's the wings up, so I'll hit A to select all. I insert a keyframe, and then wrap them down quickly over the course of like 6 frames. Bring them down. So I'll come here, then again hit Alt-R to go back to the rest position and get the downward one. So start with that inner one. So rotate around the Y-axis, bring it down. Next one, rotate Y, bring that down a little. Next one, rotate Y, bring it down a little. Rotate Y, bring it down a little. So that hopefully it'll look like flapping. The important part is just the steps, I guess. So again, repeating all that, rotate around the Y-axis each time. And then we have like flapping down. Probably be moving the head or tail or something with it, but that'll work for the steps. And then again, select all of the bones and insert a keyframe to lock all 3 of our transform type of data in place. So if we go back to frame 21 here and run this, hopefully it's not too jumpy on the Zoom call, but it kind of looks like flapping wings. Did that seem a little easier than the 2D version? I guess really that question's more for after you've had a little bit of time mess around with it. But that gives us 2 animations we can use now in 3 dimensions. But the example we're doing after the break is a 2D thing. So we need to make a slight adjustment for 2-dimensional stuff. And I'm going to use the one I sent out yesterday after the break, because there's 2 other things with animations I want to look at that we're just going to talk about, but they're in that folder that I sent out, so you can look at them and see what the difference is. But that was about 1 hour and 15 minutes. Seemed like a good time for a break to everybody. 10 minutes. Does that sound good?
Yeah, that sounds good.
Okay, making sure nobody needed an little extra time or something. Like my stomach's growling too hard to even pay attention. But yeah, so we'll be back in 10 minutes, 2:25, and then we'll finish up the 3D graphic stuff, our very brief introduction, and jump into GameMaker, which is really easy to use. So I will see you all in a few minutes.